I just want to start by thanking the PhD office for organizing this event, and then thank you all for participating. So today I'll be talking about influencer advertising on TikTok. And this is a joint work with Junjun Zhang, who is at MIT, and Yuhan Zhang, who is from Tsinghua University. So you might be wondering, who is this guy in the background? His name is Li Jiaqi, and he is one of the most iconic beauty influencer in China. And this video I'm showing you is one example on the original Chinese version of TikTok, which is more mature in terms of integrating e-commerce features. So for instance, you can see on the bottom left of the video, there is a yellow shopping cart superimposed on top of the video. And this is a product link. And when users are viewing the video, they can click on this link to be directed to an e-commerce website where they can purchase the advertised product. In this case, would be the lipstick. And also on the right-hand side, you can see a bunch of engagement metrics, meaning the number of likes, comments, and shares generated by this specific video ad. And I was quite surprised when I was researching this. So apparently he sold $145 million worth of lipsticks on a single day. That's just crazy. And Li Jiaqi is just one of the 3 million influencers on TikTok. TikTok is the largest social media platform for short videos in the world. It has over billions of active users and also collects over billions of advertising revenue. It was also the most downloaded app in 2020. And quite recently, TikTok is getting popular as a new venue for influencer advertising. So influencer advertising is a quite big and quickly expanding market. And influencers, they tend to have this dual identity on the platform, where on one hand, they are content creators who create captivating material to engage a sizable number of followers. But on the other hand, they're also marketers who monetize the attention of their followers, usually via advertising. It is a big and important space, but it has its own challenges. So a major pain point, which is also the question we're asking in this paper, is a quite basic one. That is, what makes a good influencer video ad? Well, from the advertiser's perspective, a good ad simply is one that drives more sales. Then the question becomes, how can we predict the sales lift of the video ads based on its content? And sales lift is defined as the incremental effect of these video ads on product sales. So influencers are very good at being engaging. But past work has shown that engagement is a poor proxy for sales. In other words, if a video gets more likes, it does not necessarily mean that also will generate more sales. And there's no systematic approach to predict sales lift based on video content before you actually post the video ad. So our key contribution is to construct and evaluate an algorithm that predicts sales lift. So we define this new metric that we call M-score. That is a very intuitive metric that connects engagement with product placement and quantifies the degree to which the product is advertised in the most engaging parts of the video. And then we evaluate our algorithm by combining video data on TikTok with product sales data on Taobao to show that videos with higher M-score indeed are more effective in driving sales. By the way, Taobao is owned by Alibaba, which you can think of as the Amazon of China. So for the rest of the talk, I'm going to first briefly talk about the intuition of the algorithm, and then I'll talk about how it is constructed and then evaluated. At the end, I'll conclude by discussing what's the practical value of our algorithm to the practitioners in this industry to help them improve their day-to-day business. So before I dig into the conceptualization of the algorithm, let me first say a few things about how do we think about a video as a data structure? We all know what a video is. We're viewing a video right now, but how do we analyze video? So a video is nothing more than a collection of pixels over space and time. Okay, so a pixel is just one tiny dot on your screen. And a single video on TikTok has over 1.8 billion pixels. And because we're doing our analysis at the pixel level, so these are like the sort of the independent variables that goes into the algorithm. So hopefully this would give you a sense of the high dimensionality of the problem we're dealing with, also the raw magnitude of data. And this is a key slide that summarizes the intuition behind the algorithm. So we first construct two key components from the videos. The first one is what we call content engagement heat map. This is a heat map over the video that quantifies pixel by pixel how engaging each pixel is. And then second one is what we call a product placement heat map. It quantifies in which pixels is the product advertised. And once we have the two, we combine them in computing this M score, or engagement weighted advertising intensity, and it captures the extent to which the product is advertised in the most engaging parts of the video. Now, let me show you one animation that hopefully further clarify the intuition. So here, the cubes are a video. So each horizontal layer is like a single frame, and the vertical dimension is time. The red region highlights the high engagement parts of the video, and the green region highlights where the product's present. And what happens in the middle, if you overlap the two, right, you can see that basically M score is capturing the overlapping area of this red and green region, which quantifies the degree to which the product, which is the green region, that is advertised in the high engagement parts of the video, which is captured in this red region. Okay. And this is just the formal definition of what I just talked about. So I'm going to skip this part. And then I'll talk about how exactly are those two heat map constructed. I'll start with the content engagement heat map, which is the red part. So we estimate this app in two steps. So in the first step, we train a 3D convolutional neural net using a large sample of videos on a video level measure of engagement, for example, number of likes, right? So we're using this cross video variation of content and likes to learn this empirical relationship between video content and the predicted number of likes. And then once we train this 3D CNN, we use it to extract a 3D saliency map over the input video. And this saliency map basically would assign an engagement score to each pixel in the input video. And this is the definition of how this engagement score at the pixel level is calculated. Basically, the saliency map would output, it quantifies how important each pixel is in driving the decision of the CNN in predicting the number of likes. And then for the product placement heat map, basically we use an object detection algorithm SIFT to match an image of the advertised product to each frame of the video to locate where and when is the product present in the video ad. And here, I'm showing you basically when I put everything together, you can see these content engagement and the product placement heat map. And M score basically is defined as the inner product of the two heat map. So how do we know that this algorithm indeed can predict sales lift? Well, we tested this by using staggered diff and diff on a sales panel of the product advertised on TikTok. So here, the key coefficient we're looking at is this beta, which is the interaction term between post, which is a treatment variable, and M score. So the idea is the following. So if videos with higher M score indeed drives more sales, then we would expect to see a positive interaction term between treatment and M score, meaning that there should be a positive moderation effect of M score on the treatment effect of the video posting. And that's indeed what we found. And the result is not just statistically significant, but also economically so. one standard deviation increase M-score is associated with about 4,000 USD increase in monthly sales, and that translates into about 12%. And our second result, looking to the, sorry, how many minutes do I have left?
Two.
Okay, great. Our second main result basically is to look a bit deeper into the heterogeneity across product types. So we find that effect is more pronounced for impulsive, hedonic, or less expensive products. And our third main result find some suggested evidence for this incentive misalignment between influencer and advertisers, because influencers, they might be more motivated to promote themselves rather than the products. And our algorithm also have many appealing features for the practitioners, and they can help advertisers to predict and increase ROI, and help influencers to aid their creative process, and also increase transparency and efficiency for the platform. At the end, I just want to conclude by sort of take a step back and talk about the bigger picture, which is this new emerging form of e-commerce where the letter E is standing for engagement and entertainment. And Connie Chen, who is a venture capitalist, she summarized this very well. She said, the next Amazon competitor is likely going to look like a social or video app and not a shopping app.